Hello guys, Mr. Thompson again with week number 5 on Sound and Light, second week on Light, and next week you'll be doing a project which you'll hear about more in the video later. Okay, I said I would give you the answers to your little work that you did last week on sound, so if you could look in your booklets or check online your activity 3 towards the end of the booklet and testing yourself in sound. Hopefully you've done this. To make it easy, you can tick it yourself, you can mark it, and I've put the words in red, which are the key words. So the first one, give one where the drum makes a sound when it's hit. The skin vibrates. That word vibrate is going to appear a lot in this topic. So part B, talking about the windows being closed, but the children could still hear the sound. The sound reached the children's ears by traveling through the air and through the window. It can travel through solids, can travel through the glass. You could have glass or window. Okay, question 2, an experiment you could try at home. We did do it in the first week by tapping bottles or however you did it, glasses, and you should have discovered that the one with the least air, which would be bottle D, would make the highest notes. The answer is D. And then another experiment you could try for yourself is elastic band, a rubber band around something and twang it. And again, that word vibrates is the answer. Why it makes a sound is because it vibrates. And question 3, again, another way you can make a sound, get a ruler or a bit of wood and clamp it or hold it on the side of the bench. I know you've all done this, and you can twang it and it will vibrate. And vibrate is the answer to part A, why it makes a sound. Jack heard the sound. What did it travel through to reach Jack's ears? It must be the air. It's pretty easy. I hope you've got this right. Part C, if you shorten the length of the ruler, again, you can try this. What happens to the sound? It is a higher pitch. Please include the word pitch to describe it. Okay, in the second part of question 3, quite clever this. If you could try and do this, it's quite tricky to do. But if you hold a bit of paper and move the piece of paper as you twang the ruler, you could get a shape, a pattern like shown on this diagram here. What does it show about the loudness between A and B? Well, A has a large amplitude, B has a small amplitude. Remember that word amplitude, and that means the loudness has decreased or wasn't as loud. What does the pattern tell you about C? Well, C is a straight line, so it has stopped. The ruler stopped vibrating. Explain the answer to part E. It means there's no movement up and down. And finally, question 4. Kumi is playing a guitar. What happens to the guitar string? Again, the word vibrate is the one that you should have in your answer. Julia walks away from Kumi and leaves the room. What happens to the loudness of the sound? Julia hears as she goes further away from Kumi, it will decrease, it will get less, it will get quieter. And part C, even when she shuts the door, she can still hear it. What does this tell you about the material? Well, it can travel through the solid door, whether it's wood or metal or glass, it can travel through solid. Okay, that's a review of the work you should have completed for last week, and hopefully you've given it all ticks, and if not, then you've corrected it. Okay, this week, the success criteria, we're going to look at colour. I want by the end of this lesson that you can name all the 3 primary and 3 secondary colours. I can explain why different objects appear different colours, and I know how light is reflected and how different colours are either absorbed or reflected. So the first statement there, you might think, yes, I know what the primary colours are, but be very careful because in physics, in science, the primary colours of light are actually different to the primary colours of paint in art. Slightly different. See if you can spot it as we go on. Okay, there is an excellent video, a 5-minute video explaining everything you need to know about mixing colours. It's called How Do Light Waves Make Colour, and I've put it on the same playlist as these videos, so you could find it there. Or you can just search in YouTube for How Do Light Waves Make Colour, and it's from Physics Wave World. So if you could pause this video, please, and watch that one for about 5 minutes. Okay, now you've watched it. You need to be on this page, which is week 5, colour. Again, I'm not mentioning the page numbers in case you've expanded your document, but you will find it week 5. Your task is to colour in the circles to indicate the primary and secondary colours. If you're doing this in electronic format, in Word still, then that's going to be very tedious for you to try and colour it in. So if you are doing it in there, then what I suggest you do is that you simply take a screenshot, pause the video here, take a screenshot of that, or search for that image online and cut it out, or cut it and stick it, paste it rather, into that page over the top of the diagram. If you do it on paper, you can color it in. Remember, eventually you'll be sending this document to us in a few weeks' time. So you could do it that way, and we'll be getting you to take a photograph of it. So just to recap what the colours are, the three primary colours in light for light are red, blue and green. Mixing red and green together, you get yellow. Red and blue, you get a colour called magenta. Blue and green, you get a colour called cyan. And if you mix all three, you can show in the middle, not labelled here, but it's white. Make sure you, as well as colouring in, you label, you name the colours so you remember them. Okay, the second success criteria is that you'll be able to explain why objects appear different colours. So why is it that if I'm wearing a blue shirt, everybody sees it as blue, but if I'm wearing a green one, they see it as green? We're going to indicate this with diagrams. So firstly, let's just go back to last week. This is a slide from last week, and I was showing you how light reflects. So you see things because light reflects off them. You see non-luminous objects because light reflects off them. That's not the full story. You had that in your booklet a few pages ago. We're going to try and explain why this book looks red. It's best done with this diagram here. So white light, you now know from the video, is made up of all colours. There's 7 colours: red, orange, yellow, green, blue, indigo, violet. When white light shines on an object which has red pigment, it will absorb all of the colours except red. And it's only red that gets reflected, and therefore the book appears red. So you can draw that diagram again if you want to take a screenshot and copy and paste it into your book. Here's 4 more. Just spend a little time looking at these 4. The top left here, if you have a blue object, then if you shine white light on it, the 7 colours of white light shine on it. 6 of them will absorb, and only the blue will be reflected. And notice this diagram hasn't got indigo. That's a kind of colour between blue and violet. But this shows you that only blue is reflected, therefore it appears blue. On the right there, similar to the last screen, the red object only reflects red. Now the bottom left one shows you what happens. If you have a white object, white will reflect all colours. So if you shine white light on a white object, it appears white. If you shine red light on a white object and it's in the dark, then the white object will appear red. And that was shown well in the YouTube video that you watched. And finally, a black object. In physics, we sometimes say black is not a colour because actually black absorbs all colours. So it appears black because there is no reflection. So spend some time getting those into your booklet, whether you're just going to screenshot and copy and paste it or actually draw it out yourself is up to you. Okay, that hopefully hasn't been too long a lesson today, maybe taking about half an hour, and by now I've possibly spoken to you on the Teams meeting, but if you're watching this before that, the next slide we're going to talk about on our Teams meeting. So if you've seen this before the Teams meeting, you'll have an idea what we're going to talk about. If not, then you know what we just talked about. Next week's project, I've already emailed your parents and told them that next week over the next week you're going to collect some materials and design and make a solar cooker. So I've got some images just off the internet here of 4 different solar cookers. You can see that they're all made of silver, made of foil or reflective object. Silver will reflect all of the light. The idea is that you reflect the light from the sun and try and reflect it all into one space. So you might be heating a pan of water or something like that. Now they use these in places like African countries where they haven't got fuel and they haven't got the national grid, they haven't got electricity, but they've got a lot of sunlight. So they can actually cook their food from just using one of these cookers, which doesn't cost very much, but it can actually cook stews and things like that without needing an oven, therefore not costing any money for the energy. So your task is that you're going to try and build your own solar cooker, and the challenge will be whether or not if you can put not a bar of chocolate, but some cubes of chocolate in the right place, how long it will take to melt, if you can melt it. We're hoping for a very sunny day next Wednesday, and if it's not sunny next Wednesday, I'll ask you to do it on another day, and we're going to ask you either to video it, that would be ideal, or even just take some photographs and share it with us. Just the physics of it, how does it work? Well, ideally, you'd probably have something like this, which looks like a satellite dish, because this is exactly how satellite dishes work. The satellite dish reflects all the rays from the radio, the TV signal, and focuses it onto one place, which is where the receiver is. So this kind of solar cooker would be a black pot, black because it absorbs all the light, could be filled with water, and you could actually heat that water up to quite a high temperature if you left it in the sunlight for long enough. A few safety precautions which I've gone through and mentioned to your parents, which is don't look directly at the sun ever. And also, if you're very successful, you may build something that heats up quite a lot. It has strong, intense heat. So obviously, you're just heating the chocolate up and nothing else. Although you can try putting water and other objects in there, but probably being careful. I'm sure your parents will be supervising you as well. Something for you to think about. You've got a week to think about it, to research it, have a look at videos online, have a look at images, collect foil. You'll need foil. You'll need maybe cardboard boxes or plastic. You'll need to glue and stick things together. And over the next week, you're going to be building that and hopefully showing it, demonstrating it to us via video that myself and Mr. Smith can have a look at. Okay, I'm really looking forward to next week. Hopefully today's lesson give you something to think about and you can get well prepared for next week's lesson. Bye for now.